In this video, I'm going to talk about the laws of indices. So let's get started. The first question is, what we refer to as indices? Indices is the plural form of index, right? Now, the first thing is, what is an index? An index can be seen as power. So you can call this index or power. So an index is the power of a given number. So if I have 2 raised to the power of 5, this 5 is the index of 2. We call this 2 the number or the base. Is the base of this index, or is the number raised to this index. So that's what index is all about. It's the plural form of index. So if you have something like this, 2 raised to power a, 2 raised to power b, you say these two are indices. So it's a plural. The two of them are indices. So now let's talk about laws of indices. So what are laws of indices? They are laws that govern how you manipulate numbers with power. So when you've got numbers with powers of any form, how do you manipulate them? How do you evaluate them? How do you simplify them? What do they really mean? So that's what we'll be talking about in this video. So before we talk about the laws, let me just give you an idea of what a number raised to the power implies. So if I have a number like this, 2 raised to the power of 5, what this means is, it means you multiply 2 by itself 5 times. So it's like saying 2 times 2 times 2 times 2 times 2. So basically that's what this power means. It means you've got 2 multiplying itself 5 times. So if you do this, that will give you 2 times 2, which is 4, times 2, which is 8, times 2, 16, and times 2, 32. So which means you don't say 2 raised to the power 5. It is not equal to 2 times 5. This is wrong. This is not what it means. It means you take this 2, multiply itself 5 times. So that is how you express or write out numbers that is raised to an integer. Okay, so let's talk about the laws of indices. So let's talk about the first laws up to the seventh laws. Up to the seventh law. So what's the first law? The first law can be referred to as the multiplication law. So this is what it means. If you have a number, let's say 2 raised to the power of a times 2 raised to the power of b, what that law says is this. If you simplify this, the result will be 2 raised to the power of the sum of the powers. So take note, for this law to be applied, the two bases must be the same. So if this is 2, this must be 2. If this is 10, this must be 10. But the powers could be different. This could be 50, this could be anything. But the law states that to simplify this, take one of the bases, right? Then add the powers, and that is the first law. So let's look at an example. So if I have 5 raised to the power of 3, and I multiply that by 5 raised to the power of 2, the result becomes 5, which is one of the bases. Then 3 plus 2, right? And that is equal to 5 raised to the power of 5. So this is the result. So let's look at another example. So let's say I have something like b raised to the power of 2a, then times b raised to the power of, let's say this time around we have 5a. So this becomes b, one of the bases, raised to the power of 2a plus 5a, and that's equal to b raised to the power of 7a. Now lastly, let's look at this example. What if you have something like, let's say 3 raised to the power of 4 times 3 raised to the power of minus 2 times 3 raised to the power of 7. So what do we do here? You take one of the bases, which is 3, you add up all the powers. That's 4 plus minus 2, then plus 7, right? And that gives 3 raised to the power of 4 plus minus 2, that's minus times plus, that's minus, then 4 minus 2, that will give you 2 plus 7, that will give you 9. So this is the result. So let's look at the second law. The second law is division. Let's call this division law. So what does this state basically? If I have a number like 2 raised to the power of a divided by 2 raised to the power of b, right? What will be the answer if you simplify this? The answer will be 2 raised to the power of a minus b. So in this case, we just change the division, the multiplication to division. And if you do that, you are going to subtract the power to simplify. So let's take an example. So let's say I have something like 7 raised to the power of 3 divided by 7 raised to the power of 1, right? Note that if you see a number like this, 7 is equivalent to you writing it as 7 raised to the power of 1. Just like you say you have just one 7. There's no other 7 multiplying it, right? Okay, what is the result of this? This is 7 raised to the power of 3 minus 1, and that will give you 7 raised to the power of 2. So that is the division, the law, the division law. And of course, if you multiply 7 by 7 here, you get 49. Okay, let's talk about the third law. The third law states as follows. In this case, if you have double power, so we call this one double power law, double power law. So what this states is this: if I have a number like this, 2 raised to the power of a, then everything raised to the power of b. So here you've got double power. You've got 2 raised to the power of a number which is a, then everything raised to the power of another number b. How do you simplify this? You simplify this as follows. You take this 2, then you multiply the powers, right? So this is basically how you simplify, which becomes something like 2ab. So what if I have a lot of powers? So let's say I have something like 2 raised to the power of a raised to the power of b and everything raised to the power of c. So how do you deal with this? The same principle. You just have 2 raised to the power of a times b times c, and that gives you 2 raised to the power of a, b, c. So this is the double power law, right? So if you have a lot of powers stacked on top of themselves, you just multiply the powers. So let's talk about the fourth law. The fourth law, we can call it the expansion law. So it goes as follows. Okay, let me write it out this way. Expansion law. So here you go. If you have a number like this, so you have a, b raised to the power of c. That is, you got two numbers, right? And both of them raised to the power of c. How do you express this? How do you expand this? You expand this as follows. You take the first one raised to the power of c, then times the second one raised to the power of c. So you can write it out this way. And you can also reverse it. So if I have something like a raised to the power of 2 times b raised to the power of 2, I can take the ab and bring out the power like this. So this is the expansion law. So this can, let me give you an example. So let's say I have something like 2 times 3 raised to the power of 2. You can express it as follows: 2 raised to the power of 2 times 3 raised to the power of 2. And this will give you 4 times 9. And that will give you 36. So let's talk about another law, which is the fifth law. The fifth law is zero power law. Zero power law. Now, what does this state? It states that if you have a number, a non-zero number, so take note, a non-zero number. If you raise that number, so a must be a non-zero number. Non-zero means it must not be zero. If you raise this to 0, the answer is 1. Note, if you say 0 is past 0, the answer is not 1. So which means this law applies only when this base is not 0. So take note, not 0. If it is 0, it is undefined. That's the result. That is basically what it is. Undefined means we really can't say what the answer is. We can't say the answer is 0. We can't say the answer is 1. We can't say the answer is infinity. So the rule states if you have a non-zero raised to power 0, the answer is 1. Okay, let's talk about the sixth law. The sixth law is known as the negative power law. So this is how it goes. If you have a number like 2 raised to the power of a, right? Raised to the power of minus a, negative power. How else can you express it? You can express it as follows. You can take it as 1 divided by 2 raised to the power of a. So what does that mean? It means if you remove the negative sign, you just take the inverse, the multiplicative inverse of 2a. So let's look at an example. So if I ask you to simplify 5 raised to the power of minus 2, right? You can write it as 1 divided by 5 raised to the power of 2. Just remove the negative, right? Just remove negative and invert it. Then that will give you 1 divided by 5 raised to the power of 2 is 5 times 5, right? And that's 25. So this is what you get. So this is the negative power law. You can remove negative sign from the power by inverting the whole expression and retaining the power without the sign. So next, let's talk about the seventh law, which is the last law in our discussion. So the seventh law is the fractional power law. So what does that mean? What this means is if you have a power that's a fraction, so if I have 2 raised to the power of 1 over a. So what this means is the power this time around is a fraction, right? How else can we express this? We can express it as follows, as the 8th root of the base, which is 2. So let me give an example. So let's say I have 4 raised to the power of 1 over 2, right? Since it is 2, if you say square root is this, but typically when it's square root, we don't put 2. But let me just put it for reference sake, because I'm referencing this 2. What you do is you take the square root of 4, then that gives you 2. So look at this other example. If you have 27 raised to the power of 1 over 3, how do you express this? You can just take the cube root of 27. So cube root means what number will you multiply 3 times? That will give you 27. So if I ask what is cube root, I'm asking you what number do you think will multiply itself 3 times? That will give you 27. If you think about it, if you multiply 3 by itself 3 times, this will give you 9. 9 times 3, that's 27. So the answer is 27. So let me ask you this: what was the cube root of 125? If you think about it, the number that you can multiply cube root, the number that you can multiply 3 times, right? That can multiply itself 3 times to give you 125 is 5, because 5 times 5 is 25. Then times 5 is 125. So the cube root of 125 is 5. So the point I'm stressing is when you are dealing with fractional power, you can just convert it into roots. And the root number depends on the number at the denominator. But note that this number has to be 1. This fractional power, so what I mean is this. If I have 2 raised to the power 1 over b, then I can just say the bth root of 2, right? But what if I have something like 2 raised to the power of a over b? In this case, you have to express it like this. It's more or less like you taking the 1 over 2. You are taking the a out and the 1 over b outside. Don't forget that it's the same thing because I can multiply a times 1 over b. If you remember our double power law, I've broken them into double power, and that will give you a over b, right? So I've taken the numerator inside and the denominator outside. What I'm saying is this. This rule applies when this power, this numerator is 1 and you have any other number here, right? So basically, this is going to be something like the bth root of 2 raised to the power of a. So this is how this will be expressed. So if I have something like y raised to the power of a over b, you write it as this y raised to the power of a. So this is how you represent. So this is a general form of this fractional power law. This is a general form. Okay, so let's now summarize what we've learned so far. Then we'll solve some past questions. So I'm going to talk about what I'm going to summarize what we've learned so far. The first law we learned happens to be the multiplication law, which says if you have a number raised to the power of, let's say, n, let's say times b raised to the power of n, times a rather raised to the power of n. The result is a raised to the power of n plus n. Just add the powers as long as the bases are the same. What if you make this multiplication through division? What if you are dividing both? Mind you, this is equivalent to you writing it like this, right? It's the same thing. How do you simplify this? You just take a raised to the power of m minus n. You just subtract their indices. Then if you have a situation like this, a raised to the power of m, then everything raised to the power of n. This is the double power law. So you take this a times mn. You can also reverse it. So if you have this, you can also go back to what you have on the left. So the fourth law we talked about was the expansion law, where you have a case of a times b, everything raised to the power of n, right? You can expand as follows: a raised to the power of n times b raised to the power of n. Then for the fifth law, we talked about zero power law. We said if you have a number that is not zero, that is a number that is not zero, raised to the power of zero, that will give you 1, irrespective of what this a is, as long as it is not zero. The next is if you have the next law is the negative power law. So that one states that if you have a raised to the power of minus m, what you get is this: you get 1 divided by that a raised to the power of n without the negative. So if your power is negative, you can knock off the negative sign by inverting, by performing a multiplicative inverse of what you have already without the negative, without a negative sign. So the last law we talked about was the fractional power law, where you have a raised to the power 1 over n is equal to the nth root of a. So that summarizes the laws of indices. Now let's solve some questions related to the laws of indices. Now let's solve some questions based on the laws of indices. I'm going to extract questions from the Test Driller UTME app. This is an app that has tens of thousands of past questions, and you can use it to search for questions related to any topic in maths. And if you can download it from my website or from Google Play Store and activate it and get the best of it. So let's look at some questions. I'm going to go to question search and I'm going to select mathematics, then topic. I want to search questions by topic. So what topic am I interested in? Laws of indices. Then it's going to extract questions based on my query. So I'm going to take questions from 2002, question 2. So let's take a look at this question. The question states that we should evaluate 343 raised to the power of 1 over 3 times 0.14 raised to the power of minus 1 times 25 raised to the power of minus 1 over 2. So let's solve this. From what we learned, we know that this is a fractional power, right? And since it is a fractional power, the result is equivalent to the cube root. That's the cube root of 343. 343. So that is the first thing you have to take note of. So the next is, how do we express this? This is a negative power, and the law of negative power states that we can simply take it as 1 divided by 0.14 raised to the power of 1. Because if you take the minus away, you invert the whole no, the entire number. Then this is both a negative power and a fractional power. So the first thing I do is to take away the negative power, and that's 1 divided by 25 raised to the power of 1 over 2, right? Then what is the cube root of 343? The cube root of 343, that is, what number is going to multiply 3 times? That will give you 343. That number is 7. Then times this expression, which is 1 over 0.14. Note that whatever you have raised to the power 1 is that same number. Then times 1 divided by, this time we want to deal with the fractional power. And to deal with that, you just take the square root of 25. So here you have 7 divided by 0.14, then times 1 divided by 5. So we can multiply both sides by 100 to make this 700 over 14, then times 1 over 5. 7 here is 7 in 14 is 2. 2 in that's in 7 is in 700 is 100, then 7 in 100 is 50, then 5 in 50, that's 10. So eventually the answer is 10. So the correct option is option B. Now we look at another question. So this time around, the question we're going to consider is from the year 2005, and that's question number 7. Year 2005, question number 7. So let's evaluate this. So we have to evaluate 81 raised to the power of 3 over 4 minus 27 raised to the power of 1 over 3 divided by 3 times 2 raised to the power of 3. So let's deal with this. So to solve this, we need to apply the laws. So to apply this law, we know that we have to take, there are several ways to apply the law, but let me use a different approach now. We can express 81 as follows. We can express 81 as 3 raised to the power of 4. In other words, how many 3 can you multiply to get 81? That's 3 raised to the power of 4. Then everything raised to the power of 3 over 4. Then minus, you can express 27 as 3 raised to the power of 3. Then everything raised to the power of 1 over 3. This is a different approach, but we're still going to apply some laws here. So let's leave this as 3 times. Then this 2 raised to the power of 3 is 2 times 2 times 2, and that will give you 8. So now we are going to apply the double power law. If you have a power that now has another power, what you will do is to say 3 raised to the power of 4 times 3 over 4. You multiply those powers. Then minus 3 raised to the power of 3 times 1 over 3. This cancels out this. This cancels out this. So you're left with everything divided by, okay, let's deal with the denominator divided by 24. So then this becomes 3 raised to the power of 3. 3 is what's left here, minus, this is 3 raised to the power of 1, right? Divided by 24. If you simplify this, this will give you 27 minus 3 divided by 24. And what's 27 minus 3? That's 24 divided by 24. And that will give you 1. So the correct option here is option B. Now let's solve the next question. The next question is from the year 2006. And that's question number 25. So this question goes as follows. 25 raised to the power of minus 1 over 2 times 27 raised to the power of 1 over 3 plus 121 raised to the power of minus 1 over 2 times 625 rather raised to the power of minus 1 over 4. So what I'm going to do here, I'm going to simplify. And how do you go about that? You can use the cube rule, the square root approach, or you try to convert each of these numbers into multiples of a particular number. So what I mean is this. I want to use an approach where I won't have to use cube root and so on. So what that means is I'm going to take this 25 as 5 raised to the power of 2. 25 is 5 times 5, right? Then everything raised to the power of minus 1 over 2. Then times 3 raised to the power of 3, that's 27. Then everything raised to the power of 1 over 3. Then plus 121 is 11 raised to the power of 2. Then everything is raised to the power of minus 1 over 2. Then times, here you have 5 raised to the power of 4. And everything is power of minus 1 over 4. Okay, so what do? We expand. Since we are dealing with double power law, you take this 5, then raise to the power of 2 times minus 1 over 2, then times 3 raised to the power of 3 times 1 over 3, then plus 11 raised to the power of 2 times minus 1 over 2 times 5 raised to the power of 5 times minus 1 over 4 times raised 4 here rather times 1 over minus 1 over 4. So these two cancels out 2. So you're left with 5 raised to the power of minus 1. Then times 3 cancels out 3, 3 raised to the power of 1 plus 11. 2 cancels out 2, you have minus 1 times 5. 4 cancels out 4. We are left with minus 1. Now we apply the negative power law, where if you have a negative number, to knock off the negative number, you simply invert the whole thing without the negative sign. Note that if you have anything raised to power 1, you can write it as 5. So if I have 5 raised to power 1, I can write it as just 5. The same thing goes to I can just write it as 3. Then plus 1 over 11. By taking away this negative, you invert this. Then times 1 over 5. So what's the next thing? Here you simplify, which gives you 3 over 5 plus the same thing you simplify here, but this time around you are going to get 1 over 55. If you take the LCM, this will be 55, the lowest common multiple, that's 55. Then 5 in 55, that's 11. 11 times 3, that's 33, plus here you have 55 in this, that's 1. So this will give you times 1, that's 1. So the answer becomes 34 divided by 55. So option A is the right option. Okay, so the next question will be from WAEC past question. So I'm going to open the WAEC app. So the WAEC past question is loaded with so many things. You've got the examiner's report that allows you to see what WAEC commented on the students' performance over the years. So you can check it out. You can download the app and check it. It has a lot of functionality, including educational games and so on. So let's go to question search. Then we pick mathematics. Then we want to search based on topic. So what topic are we interested in? Laws of indices. Laws. You don't have to be precise with your spelling. Law or laws of indices. The app is smart enough to extract question based on what you asked. Okay, so we have the following. So we're going to look at question 3A from the year 2002, and that's theory question question 3A from the year 2002. That's question from the year 2003, rather. 2003 question 3A. So let's take a look at this. So let's solve this WAEC question 2003 question 3A. So the question is 625 raised to the power of 3 over 8 times 5 raised to the power 1 over 2 divided by 25. So what we want to do first is to express everything as powers, right? So what that means is we can write 625 as multiple of 5, and that's 5 raised to the power 4, which will give you 5 times 5 times 5 times 5, which will give you 625. Then raised to the power of 3 over 8, then times 5 raised to the power 1 over 2, then divided by 5 raised to the power of 2. Why is 5 raised to the power of 2? 5 times 5 will give you 25. So what we want to do is to apply, let's simplify this, which will give us 5 raised to the power of 6. We have to double power. You will multiply the powers. So that's 3 over 8, and times 5 raised to the power 1 over 2 divided by 5 raised to the power 2. Then if you simplify this section, you get 4 in 8. That will give you 2. So that's 5 raised to the power 3 over 2. Then times 5 raised to the power 1 over 2 divided by 5 raised to the power 2. So the next thing is to simplify this. So we apply the laws of indices here, which includes the division, the addition law, the multiplication law, and the division law. So we take 5 raised to the power 3 over 2, right, plus 1 over 2 minus 2, because this is division, so we subtract. So that gives 5 raised to the power of, if you take the LCM, that will give you 2, right? 2 in 2, that's 1 times 3, that's 3 plus 2 into 1 times 1, then minus 1 in 2, that will give you 2 times 2, that gives you 4. So here you have 5 raised to the power of 4 minus 4, and that will give you 5 raised to the power of 0. And now, whatever you have that is not 0 raised to the power of 0 will give you what? So this, if you can recall our 0 power law, you know that this will give you 1. If this number is not 0 and the power is 0, the answer is 1. Okay, so this is the answer. So we're going to look at our final question, which is 2005, WAEC 2005 question 2A. So the question goes as follows. Here we have 2 divided by 64 raised to the power of minus 2 over 3 divided by 125. So we can write this as follows. So this can be written as a multiple of 2. 64 can be written as a multiple of 2. So how many 2 multiply itself? How many times do you multiply 2 by itself to get 64? That's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, and times 2, which is 64. So it is 1, 2, 3, 4, 5, 6. So it is 2 raised to the power of 6. Then everything raised to the power minus 2 over 3. Then divided by 5 raised to the power. How many times we multiply 5 by itself to get 1 to 5? That is 3. So here you have 2 divided by, you can simplify this section, which is 2 raised to the power 6. We are going to apply double power law because you have double power, so you multiply, right? Minus 2 over 3. 2 in 6 is 2. Then 2 times minus 2 will give you minus 4. So we're going to have something like this. We're going to have 2 divided by 2 raised to the power of minus 4 divided by 5 raised to the power of 3. So what the next step? The next step is to apply the law. So here you have 2 divided by minus 4. You can write 2 as 2 raised to the power 1. They are the same. So that you can write as 2 raised to the power of 1 minus 6 is division minus 4, because you are subtracting minus 4 from it. So this 5 raised to the power of 3, and that gives you 2 raised to the power of 1 minus times minus gives you plus. And then you have 2 raised to the power of 5 divided by 5 raised to the power of 3. So if you want to simplify completely, you can express this as 2 times 2 times 2 times 2. That will give you 32. That's 2 in 5 places. And then you have this as 1, 2, 5. So this is the answer if you want to express as a fraction. So this is what you're going to get. So that's the solution to this question. So this brings us to the end of today's video. So look out for the next video.